So let's go ahead and solve this problem. We've got this marble moving through a liquid. First of all, draw a picture. That's really important. It's falling through liquid. This is mass M. What is this force right here?
Gravity.
Gravity.
Okay, so you guys, you can't say gravity because they'll actually mark you wrong in the AP exam. I'm glad that came up. If you say gravity, it's ambiguous. What is this? What do you got to say about this line? It's a vector force.
Force of gravity.
Force of gravity. So you could use Fg. That would be acceptable. Or you could use M times G. When you say gravity, it's ambiguous to mean the force or the gravitational acceleration, which is the same as the field. That's one of the forces. It's falling through water, though. What is the other force that's acting on this thing?
The force of water.
Yeah, it's a resistive force. We'll just call it R for resistive. It's similar to friction, but what they're telling us is that the force is proportional to the V. The resistive force equals B times V. So BV. There we go. So this is a situation where the resistance is proportional to the speed. And that happens when you're going through a liquid or you're going through air. The faster you go in your car, the more resistive force you get. Now the question is, what are the SI units of B? What do we need this quantity to be? What are the units we need for that?
Mass times meters per second squared.
Yeah, we need newtons. Newtons. So this is for A. So newtons are equal to, 1 newton is equal to 1 kilogram times meter per second squared. That's what a newton is, right? And notice that our V is in, note that V is in meters per second. So we need B times V. B times V is going to be equal to B times, I'm just going to put the units, meters per second, is got to equal these are, the symbol for units is you just put them in brackets like that, kilograms meters over second squared. Okay, so how do I get the units for B? You could literally just solve for them. Is there anything I can cancel on both sides?
Meters over seconds.
I can cancel that meters. I can cancel one of the seconds. So this gives me the units of B are what?
Kilograms per second.
Boom, that's it. Okay, now does that make sense? It's kind of like just solving everything, but just using the units, right? The units for B are kilograms per second. Now what I want to do is I want to find an expression for the terminal velocity of the particle. Now we have to understand what terminal velocity is. What does terminal velocity mean? Anybody know?
It's not accelerating anymore.
It's not accelerating anymore. So that means that the net force has to be
equal.
I wouldn't quite say it that way. The net force has to be zero. That means that this force has to be equivalent in magnitude to that force, right? So I'll do it the long way. Net force Y equals 0. That means that R, I'll make up positive. It doesn't matter which way you make positive. You could make up positive. Actually, we're going to make down positive a lot too. In this case, that'll be R minus FG equals 0. One more step, that means BV minus MG equals 0. But this is only true if this is V term, right? It's only not accelerating if that's the terminal velocity. Now, Rave, did you understand what I did with that equation? I knew it's not accelerating, so I know the force is 0. I just get more specific about those forces. I get even more specific. And because we're at terminal velocity, it's not accelerating. That's why the net force is 0. I'm putting in V term for right there. Does that make sense so far?
Yeah.
Great. Now, how do I get an expression for the terminal velocity? What do I do?
Solve.
You solve for V term and you're done.
Okay.
D times V term equals mg. So V term equals mg over B. There it is right there. That's the terminal velocity. We got it.